Dear students, in today's class, we are going to see a question from Haloalkanes and Haloarenes. The question number for that chapter will be question number 32. So there two topics are there. Out of those two topics, one will be there in your supplementary examination. So the question will be like this: write equations for the steps SN1 mechanism of conversion of tertiary butyl bromide to tertiary butyl alcohol. You have to write a mechanism, especially SN1 mechanism. If you don't remember all those things, just remember SN1 mechanism. So first of all, I will write the reaction of tertiary butyl bromide. Tertiary butyl bromide contains 4 carbon atoms, in which one carbon atom is surrounded with 3 other carbon atoms. This will be called as tertiary. This carbon atom bonded with 3 other. So tertiary. Butyl. Butyl means total 4. Bromide. Okay. This is the tertiary butyl bromide. When this reacts with KOH, potassium hydroxide, it gives, here OH is a nucleophile. You should remember OH is a nucleophile. Here Br minus or Br will be nucleophile. OH minus substitutes the Br minus, so it will be called as an nucleophilic substitution reaction. Here it will be changed into tertiary butyl in the place of Br, OH. OH will be there. So remaining K plus K and that Br forms KBr, potassium hydroxide. So this is tertiary butyl alcohol. In this reaction, tertiary butyl bromide is converted to tertiary butyl alcohol. Actually, the question is, you have to write the mechanism. You should not write this. I have just given this. You have to write mechanism. For SN1 mechanism, SN1 mechanism has 2 steps. Remember this, SN1 mechanism has 2 steps. I will write mechanism for this mechanism. In that 2 steps, first step 1. In step 1, let us take tertiary butyl bromide. Tertiary butyl bromide. This tertiary butyl bromide. First, this one changed into. So this tertiary butyl bromide, before KOH attacks on this, the OH minus attacks on this, the KOH reacts with this. First, in the first step, tertiary butyl bromide will be forms, gives a tertiary carbocation. This step also be called as formation of. This step can also be called as formation of carbocation. Carbocation. Formation of carbocation. You can write a heading for step 1, formation of carbocation. This is tertiary butyl bromide that will be converted to Br minus will be separated. So here plus Br minus I have separated. Remaining CS3, CCS3 and CS3 here. This carbon gets a positive charge. This is the most important thing. If you neglect this will be not called as carbocation. Here the valency of carbon is 4. 3 is satisfied. Remaining 1 is not satisfied. So carbon gets a positive charge. This is the formation of carbocation plus Br minus. This is first step. So this step 1. So for this you may get 1 marks. It is not required. This is actual required thing is this one. In next step, step 2, we will name the reaction for step 2. For this carbocation, nucleophile attacks on this. For this, in step 2, nucleophile attacks on this. So the nucleophile is OH minus. So I will write carbocation CS3, CCH3, CS3. This is positive charge. Same we have to write here. For this, OH minus plus OH minus nucleophile attacks on carbocation. This carbocation attacks on carbocation. I will write here CS3. So OH minus attacks on carbocation. Very simple thing. Negative charge nucleophile attracted by positive charge this carbon. So carbocation, OH minus attacks on carbocation. This step is called as attacking of nucleophile. I am not getting space here to write. I will write once again. This step is called as attacking of attacking of nucleophile. So I will write same CS3, CCS3, CS3, that is carbocation. OH minus attacks here. OH minus attacks on carbocation. So it forms C, CS3, CS3 and CS3 here. So the C is bonded with OH. You can write here the name tertiary butyl alcohol. This is tertiary butyl bromide and this is tertiary butyl alcohol. You have to write name here, tertiary butyl alcohol. Tertiary butyl bromide in first step converted to carbocation. So this is carbocation. In second step on carbocation, OH minus from this KOH attacks on this. You will get tertiary butyl alcohol. This is two step. For these two step, you will get 2 marks or 3 marks. For first step, write the name, formation of carbocation. If you want to write something here means you can write. For supplementary students, I don't think that it is required. So you can write formation of carbocation, write something, and you will go to this reaction. Next step to attacking of nucleophile, and here most of the students will do mistakes if you not write this positive charge on this. So that shows that carbon, the valency of carbon is not satisfied. So at that time you will lose the marks. So you have to write this. You will get 2 marks. It is not required, but these things based on these are there. So I have written. This is not required. But if you want to write means, you can, if you know this means, it will be easy to write. Okay, directly you can write only mechanism, 2-step mechanism for SN1 mechanism. Okay, note it, practice it. Definitely the question is asked from question number 32, A or B, but you will definitely write this, practice it, that it will be helpful for you people. Directly I will go to next question from same question number 32. Write the equation. They will, or else I will write like this. Explain. The question is like this. Explain SN2 mechanism with an example. SN2 mechanism with an example. Or else they will ask, explain SN2 mechanism by taking the example of methyl bromide, by taking example of methyl bromide. Or else they can also be called, asked as, explain SN2 mechanism in the conversion of methyl chloride into methyl alcohol. Methyl chloride into methyl alcohol. First of all, I will write the reaction CH3Cl. This is methyl chloride plus KOH, same example. This is also nucleophilic substitution reaction. Here OH minus, here OH, this is a nucleophile which attacks on this carbon and replaces Cl from this. So it will be converted to CH3OH plus remaining KCl. So this is methyl alcohol. Methyl alcohol. This is methyl chloride. Methyl chloride. Methyl chloride is converted to methyl alcohol. This reaction undergoes SN2 mechanism. Now this SN2 mechanism has only one step. Remember, SN1 mechanism has 2 steps. SN2 mechanism has 1 step. In examination they will ask only mechanism, not this reaction. So same as like previous, this reaction is not required, the mechanism is required. The mechanism has only 1 step. I will write directly mechanism. Only 1 step, no need to write step 1, step 2. So here CH3Cl. Here for this reaction you have to write structure or orientation of this methyl chloride like this. C is bonded with 3 hydrogens. It is bonded with 3 hydrogens like this. Okay, so now here is Cl. Cl is there. So now for this OH attacks on here in this mechanism directly. No need to go for carbocation and all those things. Directly OH, nucleophile OH minus attacks on this compound. Especially it cannot attacks on hydrogen. It cannot attacks on hydrogen or Cl. It attacks on carbon. It It attacks on carbon. So this Cl is also nucleophile. OH minus is also nucleophile. It cannot attack here. Here already one nucleophile is there. So OH minus attacks opposite of chlorine. Chlorine on this nucleophile. Attack OH minus attacks from opposite side. Attacks from here. So it forms a transition state like this. These are seen. Here Cl is there. Here it bonds OH. OH. You have to write OH like this, OH, because O is bonded with C, not H. So now here OH minus Cl both will come to join this. Here carbon valency 4, you cannot write 5 bonds here. So here you have to give the partial bonds for these two. Partial bonds. So this state is called as transition state. Transition state. So both OH and Cl, both nucleophiles are partially bonded to carbon atom. In final, next step or next reaction, the Cl will be removed out. The remaining C is bonded with H, H and H. So that will be 3 hydrogen. Here it is bonded with OH. So plus Cl minus. This is methyl CH3OH, methyl alcohol. You have to write only this mechanism in examination. You may get 2 marks or 3 marks. Sometimes this question is asked for 2 marks, or sometimes this question is asked from 3 marks. Remember, question number 32, Haloalkanes, Haloarenes chapter. So this mechanism containing only one step, where CH3Cl, CH3Cl, same time OH minus attacks on carbon atom from opposite side of chlorine. So at the next state, transition state, means it is not completed state. In transition state, both Cl and OH will be attached to carbon, partial bonds will be there. So here, if you remove completely Cl, OH will be there. So it is methyl alcohol. Better you can write the name methyl alcohol here. Here methyl chloride. Methyl chloride. So this is SN2 mechanism for one step. The difference between SN1 and SN2. The whatever may be the question, remember these two, SN1 and SN2. SN1 has 2 steps. First step is formation of carbocation, and second step is attacking of nucleophile. SN2 mechanism has only one step. Both the nucleophile, one nucleophile remains there only, and one more nucleophile attacks on opposite side, and finally it forms a compound. It forms this molecule methyl alcohol in SN2 mechanism. If you compare both these two mechanisms, you can remember and you can easily write. Practice this one, it will be helpful for you people in examination. Definitely you will get 2 marks from this, either 3 marks or 2 marks. Okay, all the best.